Hello everyone, this is the video lecture for Pre-Calculus Section 8.1 Polar Coordinates. So I'm actually going to be using formulas that we've already seen that I've already presented to you. Here we go. X squared plus y squared is equal to r squared. That's Pythagorean theorem. We have tangent of theta is equal to y over x. We've seen that a lot. X is equal to r cosine theta, and y is equal to r sine theta. These are used to go back and forth between polar coordinates and rectangular coordinates. And it depends on what you got. These are rectangular. Rectangular meaning, you know, x and y, like that. That's what we normally use. Polar coordinates are using r comma theta. R comma theta. Here's a weird little example here for a second. Let's just say they say 2 comma 3. Draw that. Where is that on the graph? And you're like, okay, well, obviously 2 comma 3. Boom, we did it, right? That makes sense. Well, hold on. If you're talking x and y, then yeah, of course, that's rectangular. But what if they said 2 comma 3 and they meant r and theta? They didn't tell you. They didn't say. They just said graph 2 comma 3. Well, now we're talking a radius of 2 at 3 angle. Well, remember that this is pi, which is 3.14. So we're sitting about right here, you know, just before it, and we're going out a radius of 2. So there's 2 comma 3. And so it's kind of confusing because sometimes they'll tell you, sometimes they don't. What should we be doing? That kind of thing. Well, it's not going to be that silly looking every time, of course. What they're going to be using are pies and, you know, stuff with pies that kind of show that it's a radian measure. That kind of helps. I guess you have to read the words to be careful about it. I'm just saying that it could look a little strange at times. Because we always think x comma y, but that is not the case here. It's r comma theta, and then they'll change it to x comma y sometimes. So just watch out as we keep going. First off, we're just going to be converting and drawing, and we're going to do the real stuff here later. So we start with r comma theta is equal to 5 comma negative 2 pi over 3. Notice that we are told that it's r comma theta. That's nice. I want to know where this is angle-wise. Well, 2/3 pi, 2 pi over 3, is somewhere over here. This is 3 pi over 3. This is 1 pi over 3. Basically, I'm talking 120 degrees. That's positive. Well, we got a negative. So a negative would be down over here. That's a negative 120, a negative 2 pi over 3. So we're here in quadrant 3, and we're supposed to go a distance of 5. So this is my direction, and then I'm going to go 1, 2, 3, 4, 5. There we go. There it is. That's the graph. So we went this angle, negative 120 degrees, and we went a distance of 5. Notice that I'm actually traveling a distance along that line. Normally we just do 1, 2, 3 on like an axis. Well, I'm going to use that idea to go 1, 2, 3, 4, 5 on this line, okay, on that line itself. Next question. 81010. So I got negative 5, negative 17 pi over 6. Again, this is an r theta. I'm pretty sure they tell you because I told you, so there we go. Well, negative 17 pi over 6 is incomprehensible for me. I don't even know where that is. But I do know that it's more than one revolution. Basically, 12 pi over 6 would be a 2. So this is 12, 2 pi. So it's negative 2 pi. We went the other way. And then I kept going. Now, I don't know how far we kept going. I would minus 2 pi from it, but I just get more negative. I'm going to add 2 pi to this, and we're going to get a new answer. Now, we've done this adding and subtracting pi's before. Do not include the pi in your calculations. In your calculator, don't do that. I'm basically just saying this guy right here, plus this guy, and then I'm going to put the pi at the end. I got negative 5 pi over 6. That's much more manageable. I can actually draw that. So where's negative 5 pi over 6? A positive 5 pi over 6 is over here. Again, I'm kind of like using the unit circle. So a negative would be over here, negative 5 pi over 6. Again, because this is the positive, this is now the negative. And then I'm going to travel a negative 5 radius. This is kind of weird. Normally, I'd just say 1, 2, 3, 4, 5, and I'd be done with it. But that is not the case. I got to go backwards, but on the same line. So this is that same line. I don't think I drew it very well. Hold on. There we go. And I'm going to go 1, 2, 3, 4, 5 backwards. So it actually ended up over here in quadrant 1. Kind of strange to go backwards and stuff like that. But it works. Okay. Next question. 81027. They give me this graph, and it's going down here. It's got 5, so 1, 2, 3, 4, 5 distance. And this is a negative 2 pi over 3. Sounds so familiar. They want to convert this into x and y coordinates. I believe that the box is just like this. I can't remember what WebAssign exactly looks like. Sometimes they do like open box and you just got to type it. Sometimes they have the parentheses and you just type the inside. Again, I can't remember on this exact problem, but we're just going to find the answer. How do we convert over? Well, we know that r is equal to 5, and my angle is negative 2 pi over 3. Well, I'm going to go to these simple formulas. X is equal to r cosine theta, and y is equal to r sine theta. And so, just plugging it in, I got 5 cosine a negative 2 pi over 3. Get an answer. 5 cosine negative 2 pi over 3. Now make sure that you're in Radian mode. I was in degree mode in my calculator, and you can get weird results. Again, I'm going to put that right here. Radian mode. Okay, so I got negative 2.5. I mean, if you want to convert it over, it's negative 5 halves. Cool. My y, 5 sine of the negative 2 pi over 3, same thing. What's interesting is when I put this guy into my calculator, I get negative 4.33012, and I do the math to frac, and I don't get anything better. So what does that mean? It means that we got to use unit circle to some degree. If you go and check out your angle down here, I think that's at 240. You would find that it's a negative 1/2 negative square root 3 over 2. My x and y. My cosine and sine. And you can see that this 5 converted over, it's basically 5 halves because of this guy right there. And so the same thing over here. I would then say negative 5 square root of 3 over 2 is my answer there. Can you see the commonality now for this? How they kind of put together themselves? 81030. I've got 6 comma 2 pi over 3. It's really a favorite number today, apparently. That's my r theta, and they say convert it over to x comma y. Okay. Again, super easy. Where's 2 pi over 3? It's over here at 120 degrees. And on my unit circle, that's going to be a negative 1/2 positive square root 3 over 2. And so simply put, I'm going to put the r in front of it and call it a day. So x comma y is equal to, I got 6. Actually, I'm going to do it like this. 6 times the negative 1/2. And then 6 times the positive square root 3 over 2. And there you go. Notice that I don't simplify because you don't need to. We're in WebAssign. Okay. 81039. I've got the square root of 18, comma the square root of 18, and they're calling this x and y. They want to convert this over to r theta. Again, this is just going to be a formula. I'm going to use Pythagorean theorem, so r is equal to the square root of x squared plus y squared. So the square root of the square root of 18 squared plus the square root of 18 squared. So weird. So basically 18 plus 18, that's going to be 36. Square root of 36 is a 6. So we got our r. My theta is basically the arctan of y over x. But before I do that, I just want to make sure that I'm going to get something correct here. I want to graph the original xy. I don't know exactly what square root of 18 is. It's, oh, is it what, 4 point something? Because square root of 16 is a 4. So 4 point something, 4 point something, 1, 2, 3, 4, 1, 2, 3, 4, and we're somewhere over here. That's what we're looking at, okay? So my angle is going to be in quadrant 1, and honestly, just between you and me, it kind of looks like a 45-degree angle, but we're going to go and check that here in a second. So my arctan should yield an easy result. So square root of 18, square root of 18, obviously that's going to be a 1. The arctan of 1 is indeed, it's 45 degrees. Now, how does the calculator result this? Hold on, let me actually do it myself in Radian mode. They're going to want radians, by the way, so don't get comfortable with degrees. I got a 0.78539 radians, and I'm going math to frac, and of course nothing's happening. How do I convert this out using my calculator? Honestly, I think if you divide by the pi, so divide by pi, and I got now 0.25 pi, essentially, and we all know that that's going to be pi over 4. Now, I don't recommend that as the primary way to do it. I do say that it is a way to do it. Honestly, primary way, I would say, well, you can, 2 ways, I suppose. You can convert over to degree mode on your calculator and just kind of look at it, or you can use your unit circle and you could say arctan, I forgot to put a 1 there, sorry guys. Arctan of 1, again, that's just y over x, 45 degrees. We already said that a long time ago. Lots of different ways to get the answer. Use multiples. That way, in case one doesn't work, you can have backups in a way. I know that you're thinking, well, I'll always have the calculator. Yes, I get that. I'm not going that direction. I'm saying, what if the calculator doesn't work one time? Sometimes, like I was mentioning in the very first problem, that little example, they don't always have to put a pi in for radians. So what if they don't? What kind of radians do you get then, you know? So just be careful. Be careful. 81042. So my x comma y is 1 comma negative 6. And again, that's xy. They want me to go to r theta. R is always the easiest. Basically, I'm just going to do this guy here. It's Pythagorean theorem. Square root of 1 plus 36, square root of 37. Doesn't reduce, you're good to go. So keep that guy around. My theta, again, I always default to the arctan of y over x. And when I put this in, I get a negative 1.4056 radians. Now, here's the thing. What's going on here? What are we talking about? Well, first off, before being too hasty, I probably should have drawn it. I got a 1x and a negative 6y. We're down here in quadrant 4. And here's the weird thing. What we just received is a negative number. Basically, I'm getting this angle right here going down. Now, is that a correct answer? I'd say yes. I mean, that looks fine to me. 2 problems. Problem number 1, they say they needed an exact form, which is scaring me a lot. This is not anything on the unit circle. Like, if you could try to find that unit circle-wise, it's not going to happen. So that's already scaring me a lot. The second thing is that they need it to be from 0 to 2 pi, basically within the first revolution when they want a positive answer. That one's not too bad to figure out. Basically, this is where we are, and I need to basically get a coterminal angle by adding 2 pi to it, adding 360 essentially. So I would then say the negative 1.4056 plus 2 pi, and I get, well, let me do this in the calculator, I guess, 1.4056. If I'm doing it in the calculator, and I already have my notes, obviously I did not do this in my notes, 4.87758 radians. And that's cool and all, but again, we're looking for exact form apparently. That's what they said on the directions. And you know how WebAssign is pretty good about rounding sometimes, but it's also picky when it really wants something in particular. Okay, so it's going to be picky in this particular case. What am I going to do? Well, all this is not good. I mean, yeah, it's good to add 2 pi. I think this is a good format, but we need to back off of our decimal. Rather, and this is why we do these kind of problems, this is a strange answer, but I want this guy and then plus the 2 pi. I'm going to leave it as the arctangent straight up, just as you're seeing it. Here, let me show you the answer. This is just so weird that I got to show you. So the square root of 37 was my r. And for my theta, I'm going to put arctan of -6, and then just say plus 2 pi, and we're done. That's actually what I typed in to WebAssign. It works. That's what they want. If you get it wrong 3 times, that's what they'll show you. So very weird there, of course. But there you go. Another thing is that it's kind of weird. You type the TAN and it'll pop open this guy. You got to back up and put that little thing up there. By now, I'm sure you're a little bit familiar with how it works, but in any case, it's kind of strange. I'm sure, very sure, that you can type arctan like this and it still gives a good result. So later on, I might be doing that in this class. Certainly, I do it in like Calculus 3. That's just kind of my thing. I like to type it out sometimes. Moving on. 8, 1, and you are all taking Calculus 3, correct? No. Just playing around. So, it would be cool if you do. So, the next set of problems are different. They're whole different. In fact, I'm going to put a big break here. Everything we've been doing, we're now like kind of tossing off. We're going to do something completely different here. It's going to be equations. We're going to convert equations. Like, here's a good example. So this guy right here is x squared minus the y squared is equal to 12. And they want to convert this into polar form. Okay. First off, I got a question for you. What is this shape? What is this shape? What are we graphing here at all? Well, to be honest, we'd have to do a lot of math to know. Like, I'm pretty sure that our Chapter 11 work here in Precalculus is focused primarily on conics, and that would be this guy right here in particular. But I'm going to go ahead and cheat and tell you that it's a hyperbola, and my major's x, so then it's going to be this guy right here, something kind of like that. Again, I can't draw a good hyperbola, but I'm going to try my very best here. There. It's kind of like parabolas, but sideways, but it's not really parabolas, so there you go. Moving on. So this is what we got here. Apparently I'm supposed to graph this in polar form now. What do you mean? Well, if you actually had like a TI or a Casio and you change your mode, and I know normally you just change between radian and degree mode, but if you go down, there's like function, parametric, polar, sequential, and all that kind of stuff. On the that's the TI. The Casio, when you go to y equals and start graphing it, at the bottom row they have different options like r equals or something like that, and you can parametric. Lots of different ways to graph, not just y equals all the time. And so we're basically trying to find a way to put that into the calculator, draw this using polar form. How do we do it? Well, you use that same set of formulas. I'm going to rewrite them because they're very important. R squared is equal to x squared plus y squared. The tangent of theta is equal to y over x. I have x is equal to r cosine theta, and y is equal to r sine theta. We're using these 4 equations again and again and again and again and again, not just in this section, not just in this chapter, not in this class, but also other classes. Like in particular, Calculus 3. So, since it's on topic, hey, you're getting that lecture experience today. What do we do? I am going to take these guys and plug them in, and let's just see what happens. So, instead of saying x squared minus y squared is equal to 12, I'm now going to say r cosine theta squared, r sine theta squared is equal to 12. Distribute the square. Again, I've been teaching here in the classroom again recently, and it's just kind of, when I say distribute the square, sometimes people try to do that for factors like this. You try to do that. No, don't do that. We're just saying both of these are squared, okay? These are just little things that I'm reminding myself that sometimes people forget. So I'm just reminding you again. They're both squared. That's basically what's going on here. Okay, cool. Now what? Well, the goal of most of these polar forms is to get r equals da 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 da. That's going to be our goal. So if I can get r by itself, then I should be good to go. Well, I can factor an r out to the front, an r squared. So then I have cosine squared minus the sine squared. And I bet that that's a formula somewhere in the trig identities and stuff back from the last chapter or two. I don't care about that right now. Again, we don't need to simplify all that stuff. We're just saying, hey, look at that, cool, let's keep moving. To get r by itself, I'm going to divide this whole factor to the other side. So we have this. Remember that I did say it was a trig identity, so if you went and got this wrong a couple times, that you'll see that it's actually, oh, yeah, I did do it on my paper. You would see what I'm going to show you here in a minute. But this is still, I think this should still work. You know what's funny? You want to get r by itself, so the next thing is you're going to have to square root both sides, right? But when you square root both sides, remember there's a rule for that. You're going to have to put plus and minus. They don't want that in WebAssign. And so what do? You actually leave it alone. It's so weird that the very first question I'm teaching you about how to do all this stuff, well, they say do it like this, and then they don't. But normally we would keep going and get an r equals da da da, and you're going to see that here in the next couple of questions anyways. This is just an oddball problem, and that's okay. We can get by. I want to convert this a little bit. This is a trig identity. I want to show you like, hey, I got it wrong 3 times and it's a completely different problem. Well, basically they're rewriting this as a cosine 2 theta, and that's another way to do it. I mean, I think that would be fine. Another way, of course, is to take that cosine and move it up as a secant. And there you go. This is still a hyperbola, okay, in polar form. But isn't that nice and pretty looking? Okay. And I even had the note still written in my notes here. It says it's kind of weird. Normally you have just r equals and you get a something, but here it's r squared. Okay. So I'm reminding you again, normally they stop with r equals, not r squared. Like here's another one. R equals 6. That's actually a polar form, and they're wanting to convert it into rectangular, x's and y's and stuff like that. What is this graph right here? Like, maybe here's the idea. If maybe I can find what the graph is, I can kind of convert it over really quick. Like, well, I'm saying that my radius is equal to 6. My question to you is, what is theta? I don't know. And that's just the point. We don't know. Theta could be anything. Theta could be everything. So every angle is possible as long as the radius is 6. That is a circle. Radius 6, radius 6, radius 6, radius 6, 6, 6, 6. Everything's a 6. Radius 6. That's a circle. We just drew a circle. Isn't that pretty cool? That's a polar form of a circle. Well, I need to convert that over to rectangular form. And again, this is polar stuff. And I'm sorry, the conics from the next chapter. But just in case, you might already know how to do this form of a circle is x squared plus y squared is equal to r squared. This is the formula for a circle. Isn't that funny? Well, it's the same as what we just had a second ago with my, well, I guess, yeah, with my polar conversion formulas, like up above. It's the Pythagorean theorem. Well, we know that r is equal to 6. So x squared plus y squared is equal to 6 squared, which is 36, and, well, that's it. Again, it's very strange that they're not going for a y equals da-da-da. That's normally the goal here, if you can. But they didn't do that today. I don't know why they're not doing it on any of these, but that's okay. Could you graph this in your calculator? Maybe. You'd have to square root some stuff. You'd have to go and do something else. Could you graph this on your calculator? Yes. As long as you put it into polar form, you just hit 6, enter, and it goes. It's pretty cool. Next question. Ooh, this is a good question. We got to do one of these guys. So I got r is equal to 6 over 1 plus sine theta. Okay. They want to convert this over to rectangular, just like we did last time here. Okay. That was kind of a different problem. But this one here, we're going to have to really do some math. I'm going to first convert everything over to, I guess, x's and y's if I can, use sine and cosine and stuff like that. Like, I do know that the sine is y over r. That's a little weird. I just want to keep the r's for just a little bit. We're going to cancel the r's soon. Often when I, like, say in the past, would do this kind of problem, I would convert this guy over to the square root of x squared plus y squared immediately, and same thing here. But I'd have this big old mess of square roots all over the place, and it's not really friendly. So rather, I'd like to keep the r around for just a couple more minutes. Multiply over here. 1 plus y over r, all times r is equal to 6. Distribute your r, and you'll notice that you get an r plus, well, actually the r's cancel, get a y is equal to 6. We're getting pretty darn close. I can convert this r back over to the square root of stuff, but let me move my y over first. That's going to be the square root of x squared plus y squared. And what I want to do here is I want to get rid of the square root. I want to square both sides. Now, is this an acceptable answer in WebAssign? I would say maybe. I would say not always, but maybe. So what I'm doing here is I'm squaring it. The reason why is because the square root has domain restrictions that these guys won't. So maybe WebAssign will take it. Maybe not. I'm not really sure, and I'm not going to test it with you here. I'm just going to keep going. And so we got 6 times 6 is 36. We'll get a negative 12y. 2 negatives make a positive y squared. Cool. Well, notice that these y squares on both sides, you can actually cancel them out. They also move these guys over to the other side. X squared plus 12y minus 36 is equal to 0. That's good, I guess. Again, I have in my notes that it probably would have taken something above. I would say maybe this guy. They might have taken that guy. I don't think that they would have taken this one. Just a thought, though, okay? Actually, this is the last question I have in this section. 066. I got r is equal to 6 over 1 minus cosine theta. This is basically the same as last time. I'm going to move this guy over. 1 minus cosine times r. I can convert that cosine to x over r. Distribute your r to get r minus x is equal to 6. Move the x over. So I got x plus 6. Well, I know that this is the square root of x squared plus y squared. And then I'm going to square both sides. This is just a copy-paste problem here. And then, would they accept this right here as your answer? I'd say probably, but again, that's for you to decide. I'm going to keep going. I'm going to FOIL this thing out. X squared plus 12x plus 36. These guys actually cancel. What I'm doing here is I'm minusing x squared on both sides. They just cancel out. And then I'm going to move all this stuff over. So y squared minus 12x minus 36 is equal to 0. And there's my rectangular equation. I think another version that they had is y squared is equal to the 12x plus 36. They just stopped it early, like up here. Both are fine. It should be fine. They're both fine for sure. Okay, that's all I have. I know I was a little long-winded there, talking too much, maybe theory, but, well, there you go. Thank you very much. Have a great day.